And now it's okay, color changed. Now it is fast.
Very good.
2 minutes only.
Ah, 2 minutes.
Now it's fast.
Let it.
Okay, so let it go on. See here, I'll just explain. Let it go on. See, once you click that control yes, so this subfolders will open. So I just close other subfolders. See this subfolder. This is where I created. Blink is my folder name. And once you click control yes, so this will create code, drivers, some etc. will be there. And what you have to do is go to code, and go to src. And here you can see that main.c. The main.c file open. It will be like this. This is your main.c file. So it means that it will give you the draft code. Okay, it will give you the draft code. Okay, in this draft code, what you have to do is you have to give the user code. Okay, so in the user code, usually in Arduino IDE, how it will be is we will be defining the mode of the pin. So pin mode, the analog or digital, whatever the things are there, that we will initialize it. And in the void loop, we will be calling it as the digital write or analog write or digital input, whatever is there, that we will define. Okay. Similarly, here how we can write this, it all commands starts with HAL. Okay, all commands start with HAL, that is hardware assembly layer. Okay, HAL is hardware assembly layer. Then HAL, here I just put you this this code may be there. Line, these may not be like open. So I just entered this code. You can look at that code. HAL hyphen GPIO. Okay, because I'm going to use the general purpose IOs. Okay, and the toggle pin. So toggle pin is the function. Okay, I'm going to toggle the pin. Okay, which pin I'm going to toggle? So that I will be assigning in the bracket. Okay, in the bracket you can see that GPIO A, that is there are multiple GPIO channels. Okay, in that my user LED is there in the A channel, so GPIO A, comma, and the pin number PA5 was there, right? PA5 was there, so GPIO hyphen pin, underscore pin underscore 5. So now that pin is assigned as a toggle pin, and this toggling will happen every 2 seconds like that. I just assigned it, nothing else. Hall delay is there, hall underscore delay is there. So it means that every 2 seconds that pin will toggle. It means that it's a kind of a blinking LED. Okay, the same thing how we can write one more way is HAL underscore GPIO right pin. Okay, so if you say right pin, I am assigning that IO pin as the output pin. Okay, so that option also there. But if I go in that way, multiple lines of coding is required. But this is just with 2 lines of code, I can do this blinking operation. Okay, that's it. No, you have to do it here. You don't need to write anything here. Okay, only these 2 lines you have to put it at the while, because it's a infinite loop. Anyone it's open? I think except Sweta. Anyone else it's open?
Sir, our register. Then it is the same thing.
No, maybe close it. We completely do it as a fresh. Completely do it as a fresh one. Sir, if you write it, it will almost because it's so infinite while for the infinite. So it will be continuously on. So this for this only I told please do the registration, it will take time.
No, we have to, while downloading the software, we have created a register.
Yeah.
We thought we installed everything.
Because it's only first time. Once you do it first time, from next time onwards, you don't need to worry about it. Since it's the first time installation, we'll ask you to do all these things. So meanwhile, I just send you some codes. You can keep it in your desktop. So whatever the test I did, I just shared the complete thing. Maybe you can practice in home also. And this boards all belong to the department. Okay, you can do testing at any time.
It's a
1,500, 1,400 from 1,400 somewhere.
I11.
Not an error. Only that link IUC is very long. You just close it and
ಅದು ಅದೇ ಯಾಕೋ ಪ್ರೆಸ್ ಮಾಡಿ ಎಲ್ಕೋ after that it is 700 daily 0.75 is there.
Okay, so I just sent you the code. You can download it and keep it on your desktop.
Wait, after completing it.
So shall I proceed further? Yes. Please, reading right. Yeah. See here. So once this two line is given, once this two line is given, how to observe the output? Okay. In Arduino, it's simple. Just compile, upload, it will upload. Okay. It's not like that. So here first you have to check if any error is there. So for that build function is there. You can see that some hammer kind of button is there. Okay. Just click that one. It will show you if any error is there in this queue. Okay. So I think some error is there somewhere. So I just check where the error is.
So this code is already presented on your right?
It's already there, sir.
No, see, I wrote only this code.
Okay, only that part.
Yeah.
You open in that window, it only
See, I wrote only these two lines. That's it. Nothing else. All other codes are by default. It will come. You don't need to do anything. So what you have to do is just scroll down. There one infinite while loop is there, and there I just typed it. Nothing else. Okay. So once it's done, so one error was there. I think one bracket was extra. So I just once again built it. Yes, you can see that there is no error and zero warnings. Okay. Once this is done, and you can see that some bug thing is there. It's a debug. Okay. So click this. Okay. And you don't need to do any setting here. Just click OK. Okay. Now it will debug, and once the debug is done, it will upload the code to the board directly. You can see that when the code is uploaded, when the code is uploaded, you can see that this is where the serial communication is indicated. It means that code is connected and communication is happening now. But see that now the code is uploaded. So all of you can listen. So the code is uploaded. You can see that there is no. Okay, so now what happened is code is uploaded, but still it is not. Your system is not allowing it to give the output. So how you can allow it is, here you can see one resume button is there. Okay, just click this resume button. Now you can see that now the LED started blinking. I just put 2 seconds. For 2 seconds it will be on. 2 seconds it will be off. Okay, so maybe you may feel that I have done something else. Maybe what I do, I just reduce this time delay here. Instead of 2 seconds, I just get 200 milliseconds now. Okay, I just stop this. Okay, once again I debug it. Okay, once again I debug. Okay, it's debugging now, and you can see that it will show for the waiting for debugging connection, and will start upload the code. Once the code is uploaded, verified successfully, you can see that verified successfully. Then you click this resume button once again. Now you can see that blinking will be fast. You can see that blinking is fast. It means that yes, whatever the user code is given, it's working fine. Correct? It's very simple. It looks tough initially. Okay, compared. Suppose if we are good enough in the Arduino IDE, this looks somewhat tough. But once you learn it, you can do a wonder with this board. Okay, so the blinking is done. Okay, the first project is done. Maybe so for you connected.
Yeah. May.
Once this is done, what you can do is open that small box. Open that small box, because I wanted to do many projects, but now it's almost 1 hour over, so I just want to go with the next one. So in that box, multiple sensors are available. Okay, so in that I just want to select only one sensor for my demonstration, and second sensor I will use it for next demonstration. Okay, you can check MPU 6050. MPU 6050. Yeah, this is what the sensor MPU 6050. Okay, it's a gyro. Okay, gyro and acceleration both are available in this board. Okay. Now, if it is not available, just tell me I'll give some other things.
This one.
Okay. So now we just look at this screen. So look at the screen. It is having almost 8 pins. All of you please listen. It is having 8 pins. Okay. VCC ground. It's very simple. It's a power pin. VCC is 3.3 volts pin. Okay, so that from there you have to connect one wire and you have to connect it to 3.3 volts and ground to ground. Then after that, multiple pins are there. What to use? Okay, so that matters here. So you can see here SCL, SDA is there, serial clock, serial data. Okay, and we have XDA, XCL. XDA is the external data and external clock, and this is for address change, and this is for the interrupt. Okay, so these 8 pins are available. Okay, so see this gyro actually it is 3-axis gyro, 3-axis accelerometer. Both are inbuilt. Okay, and this is also having I2C module. It is also having I2C. Okay, inbuilt. Everything is inbuilt. Okay, so now if you connect serial clock and serial SDA, it will directly connect with your board. If you want to connect this directly with your board, you have to use SCL and SDA pin, serial clock pin and serial data pin. Okay. Suppose some master sensor is there. Okay, slave sensor as shown. Okay. This master to slave, if you want to connect, what you have to do is you have to connect with yes. Particular I2C is having its own address. It is one address. Okay. If we want to change, okay, you have to go for. This one is the external interrupt. So for our purpose, we are not going to use this 4 pins. You please avoid. Okay. Towards the ground, SCL2 side. This side, okay, you can see that is D14 and D15 pin. You can observe.
Not this one, not this one, not this one. If it's sensitive, which one is that? The bone. Bone. That should be like that.
I said, please open the code also. Download the code and keep it off.
The bone is not. Bone is not that.
MP is not there. No other connections. VCC. Now it's working fine. Maybe you can test that also. Somehow it just bend it and use no other way because they gave that way only. Because I just brought my cable, it's not there. So somehow slightly bend it. See both the sides, you slightly bend it and insert. Not given, it's only they provided.
Jumper heads from the
Sensor stuff we have. No. Where it is there? No. Sir, ask the Kiran to bring. Where to bring? Just ask him to be here. He's here only. Code. It's done? You connected? Open the code, sir. I think for Balamudans are also working now. Folders are coming for you. Switch off. Not the
folder. Where is the code, sir? Code.
So for blinking, no? MPU logger. MPU logger.
76RG.
I think everyone connected. Shall I proceed? Yes? Okay. So once after connecting, so once again we will create. See, before that I'll tell you why I'm doing this. So before that I'll tell you why I'm doing this. Now I just want to go for some classification problem. Okay, I just want to go for one classification problem. Here, the case study actually what I wanted to give you is, we wanted to fix the sensor on any of our machine. Okay, and with the vibration analysis, I want to vibration, I can say that my machine is loaded. Okay, with the vibration, I can see the speed which is running at this speed or that speed, like that. So classification. So I need some time. Okay, so but we don't have any vibrations in our box. We have some. Inside what we already use this gyro, because this gyro, as I told, it's a 6-axis. Even the small variation, analog value will change. I will show you when I give the demonstration. Yeah, we consider all three axes. Yes, that's what I'll tell you now. So now instead of placing the sensor on, see, for example, if I keep this sensor on machine is vibrating, right? So all those values will be displayed. So with that data, I can easily predict, or I can easily classify my machine is loaded or unloaded. Okay. So now what I want to do is, I don't want to go to the machines lab, so I just want to do on table itself. For that, what I instead of what I'm doing is here axis detection. Okay. So I want to detect the data for XY axis, YZ axis, and Z axis. All three axes I will collect the data. I will when I move XY, it should show XY. So it means that classification is happening properly. Okay, that is what we are going to do now. So we'll give cables to all, four cables to all. It's male to female now.
Male to female.
You have to collect it back once this is over. Yeah. So for that, before I'm going to the classification problem, I use IDE to enable the I2C module, because by default the I2C module is not enabled on your controller. I have to enable this I2C. Okay. Once I do the enabling, I will just connect my serial monitor here. Through the serial monitor, I will observe, okay, what are my access values when I move it. Okay, that we will observe. Once that is done, then we will go to the nano engineer. So in order to do this, what I have to do is, you close this, I just open the IDE once again. Okay, go to File. Go to File, again go to New, STM32 project. Okay. Yeah, so this window will open. Select the board selector, okay, and type Nucleo L476RG. Okay, select this, and your right side, bottom side, you can see that your board will display. Select it and click Next. It will ask you to store the state of file with some project name. I just keep it in my folder. I just go to my folder now. So where I just put it as
File name. What is it?
yes, yeah. So just put the test folder, and here I just save some more folder name, MPU, LPU, logger. I just put something. Okay, so here I just want to save, and my file name is MPU log. That's it. So once this is done, click Finish and go with the default mode. Okay, once again it will open everything. Once again that the controller part will open. Okay, this is the controller part. I just close all the things. All the things I close it. So this is what the controller part. Okay, so now what we have, as I told you already, this STM, the nuclear board, is going to communicate with the NPU sensor through I2C. Okay, so for this purpose we have to enable the I2C module. Okay, so for where we have to enable is, you see that for this purpose we have so much of modules. I2C, as I told, it's not having only one I2C, it's having multiple I2C. I am going to enable only one I2C. Which I2C is PB8 and PB9. I am going to enable it. PB8 and PB9. You can see that PB8, PB9. Just click on PB9. Just click on PB9. It will show the multiple options. Right. And here you can see that I2C1 SDA. So that I will enable it. Okay. And PB8 I2C1 SCL. So this I will enable it. So now I selected the pin. I selected the pin which can communicate with the MPU. But still we are not enabled, because when you enable it, it will show in green color. But you see that still it is in yellow color. So what you have to do is, here you can see the option called connectivity. Click the connectivity, okay, and you just look at here, there are 3 I2C modules. But what we have enabled is the first one. So click this I2C one. Okay, and see that here it is showing disabled. So you just click it and just enable it I2C. That's it. Once you select it, what you have to do? Click Ctrl S. Click Ctrl S. So now you can see that. Now you can see that under MPU log folder, multiple folders are automatically created. Okay. So as I said, we have to open that main.c. We have to open that main.c, and then we have to enter code. Okay. So for this purpose, what I am telling, what the code I have sent you already, you please open that code. The code what I have sent already, please open that code.
There only sir.
Yeah.
There only put, sir.
See, this is the code what I sent you. This is the code what I sent you, but this is the code what by default it's open. Okay, you can see the difference here. It is having only hash include main.h, only that header file is included. But when you look at the code what I have sent you, it is having multiple things. Okay, hash include at stdio.h, string.h, all used in BE first semester, second semester, we have used in the next study. Yeah. So this is only while the first two things are useful, those header files are very useful to display the values on the serial monitor. Nothing else. Okay. And the next one is very important. Okay. Hash include MPU.h. Okay. This is the header file for this MPU sensor. Okay. This sensor, obviously, if you go to the Arduino IDE, we have a lot of open source. The libraries are available. Okay. So this is again open source header file only. I have taken, and that header file also I sent you. The header file also there in that folder. Okay. Where you can find this in that MPU logger file folder is there, right? MPU logger folder what I have sent you. That MPU logger folder, one INC folder is there. INC folder. You can see that INC folder. I sent the bulk code to you, right? So in that one folder called NPU logger, that is the code what we are doing now. You open that folder, inside multiple folders are there. One is SRC, other one is INC. In SRC only you have main.c. Then in INC you see that there are file called MPU.h. It is a header file required for this MPU sensor. Okay, it's an open source. We can directly take it from online in this mode. It's not a problem. Okay, you don't need to worry about that code. Okay, just copy that file MPU.h file and put it in your SRC file, your INC folder. Copy that. Okay, copy that on only MPU.h. Only MPU.h. See here what I am doing. I am just copying that. Okay, and where is my folder is? I just put here. You can see that this is my folder. Go here and here you just paste it. MPU.h. That's it. So what I did? I repeated once again. If you want to connect this sensor with the board, we need a header file for this particular sensor. The header file for this particular sensor is MPU.h. That I sent you already. That file you copy, okay, and keep it in INC folder of the file what you are doing now. That's what I did here. Now you can observe under INC folder I have MPU.h file now. Under INC folder I have MPU.h folder file now here. Got it?
Yes, sir.
It's done? Yeah. The next, open that main.c of your file and open the main.c of the file what I sent you. Both you open. Hello? Yes, sir.
400.
So now one is it.
This one.
Yeah, I sent some of this. Yeah.
That is how much. Now. Is open from that. Yes, this is.
It's just replace of hands. And just I don't know for what purpose. If something is asked, you just ask. Hello? Send that one. I will send it. Yeah, okay. So you open two main file. One is the file what you are doing, main.c file. The other one main.c what I sent you. Okay. So what you do is the main.c file what I sent you, just Control A, copy and put it in your main.c file. I'll explain the code. It's just very simple thing, not a big thing. I'll just explain it. Yeah, fine. It's clean. Yeah. So just save it. Okay. So I just explain you. I just put it like a stepwise. Maybe in my file, what you can see that step by step I put where are the changes to be done. So first step, the first change what you have to do is this three header files you have to include. Hash include stdio.h, then string.h and mp.h. This is the first change you have to do it. And this is the second change. Okay. This is the step 2. So here you can see that I just defined the access number. So the sensor what I'm going to use is a 3 access. Okay. So I just put one variable name access number and my actual value is 3. So I'm going to use 3 access. Okay. Then once again I'm going to declare another variable data input user. Okay. So that is 256. It means that why I put 256 here is I just want to take 256 samples of the data every time, for every second. Okay, it will take the 256 the strings of data.
You can change.
This you can change, but by default it should be 1 because for 3 axis this is minimal requirement. This is the second change, and the third change, this one you can see that float MPU buffer access number into data input user. This is very useful to collect the raw data from the sensor. Okay, just here I declare it. In that declaration itself, what it will do here I mentioned that you can see that access number into the data input user is nothing but 3 into 256. So it will collect all the raw data. This is step 3 change, and the step 4 change. There are 3 functions. Okay, there are 3 functions. Okay, so this one is for only to display the values on serial monitor, and this one is to collect the data from the sensor, and this one after collecting it we have to log it. So for that log function. So there are 3 functions. All 3 functions you can find it at the bottom. So this is the 4th change. And this is the 5th change. You can see that MPU 6050 underscore initialization, and for every second, okay, every second it will do the initialization. Okay, maybe you can look at the code maybe at the later stage also. I don't want to give the step-by-step explanation. So all the 3 functions what I told, the log function and serial display function, okay, and the raw data collection function. All these things are defined here. You can see this is this data, and this is for logging the data. Okay, this is for logging the data. So there are 3 functions I put it. Okay, save it. Save it. One more thing, as I told you, I want to see all the data on my serial monitor. Okay. You have to enable one function. What is the function is? Just right click on the folder what you have created. So I created MPU underscore log. Okay, I just right click on it, and you can see that properties. Go to properties, and there you can see that C bar C++ build. Okay, can you see that? C bar C++ build, and under that you can see settings.
Just one alone have a computer.
Here it's okay. Just a second. General. Just a second. We check now. Just a little bit. Yeah, it's fine. Monitor. So in that Arduino, you know, your right top corner serial monitor will be there, that you will click and show. But here it's not like that. How you can, at the bottom right side, you can see that open console button is there. You can see that open console. Okay, and this you click it will show the command shell console. Command shell console.
Which one is not required, sir? C bar C++.
No, that's not it. You leave it. Close it. Close it. You just built it. See that any error.
No error.
No error, no? Then you can go for debug. So once again I repeat, click that open console, command shell console, and here you can see the connection type. It will show the multiple connection type. I'll select serial port, okay, and here you can see that new button is there. Just click this. It will display your serial port automatically. So for me, the serial port is COM11. By default, it is there. You can give any name here. I just click some name, random name.
Click on debug.
Yeah. Okay. Okay. Yeah. No, just move it and continue. It's done. So serial port you don't need to change. If it is not displaying the serial port, it means that the board is not connected. Okay. So by default it will show the serial port, and I have given some connection name also. Just any name you can give, no problem. Click finish, and it will show the connection name here. Whatever we created now, it will show the test file what I was created. Okay, and click OK. Just click OK. And you can see at the bottom, test 5 is connected. So now the serial monitor is open. Okay, serial monitor is open, but you see that still it's not showing the value. Okay, if you want to see the value, what you have to do is you click the resume button. Okay, take some values of the then my sensor is not connected properly. It will show the value. Or anyone is showing?
So it is TP, that link is not detected.
No, you remove it, sir.
I remove
Remove it, completely remove it. Okay, then you connect it, and you see that other things are connected properly.
Yes, sir. For debug,
For LED programmers, it's not worked.
no, I
No,
know
that
that
is there.
it's connected.
And this board is not working. Use that board and connect. So the values are actually displayed.
New project. New project. New project general just close the console. Just close hold the copy, basically main notes.
I think it's working, but it's not displaying the values of charge.
Program changes is already done. Program that is done. After that, default step test. Console and default test correctly. My console is
It's connected, sir. The sensor is having problem.
after that, you right click properties. What you have done.
No, sir, not connected.
That's
It's connected.
You just right click
Check,
on the temporary
what
option
change
and go to
maybe
properties.
to change the cable and check otherwise.
Properties. And then go to see direct appliance build.
It is already there.
Apply and close.
Let's go to errors will be
Because we have copied the program.
just layers.
It can be different.
After this, auto section console.
I think it will work now. Yeah, so you can observe the values are coming now. My see that I'm just changing my sensor. You can see that I'm rotating the sensor now. You can see that the values are getting changed.
Sir, can give the meaning of background?
No, this is only for testing. Our purpose is managing. This is only for checking that sensor is working or not. You can see that sensor is working. So every second it is capturing the data and it is giving it to my console. So in my console I can see that I'm just varying it. So based on my variation, all my access values are getting changed. So it means that my board and my sensor is ready to do ML work now. So up to this you got it right. So why it was not showing you previously? Yes, I just tell you. I forgot to tell one step. I told you no. Just right click it, go to properties, and there go to C or C++ build settings. You go in that MCU setting. That MCU setting. There, what I have done is I have not enabled it. This one, use float with printf. Okay, actually the float is not enabled. Yeah. Yeah. So for that you go to this step you do it.
What is that, sir?
You just right click on the folder, go to properties and go to C++ build setting and MCU bar MPU setting. MCU bar MPU setting.
Second option.
Second option.
Second option.
Yeah, there you can see that use float. Yeah, that you click it and apply and close. You got it now? So now you debug it.
But sir, that
That
the setting,
Not combined.
Not
Not combined.
Once again.
You have not given correctly. See, on the folder, this is the folder, right? On the folder, settings, MCU settings, and
float.
that's it. Now you see that error has gone. Now you can print.
After that we have to go to console.
Debug. Debug. Maybe your port is you connect to the other port.
Okay.
Now what we do?
Check on this.
You have to create debug errors.
No, madam. It's not like that. It will show. See, once you go to
You have given your
open console, there only will show the count finish. Or else what you can do, you see that the device is connected properly. Go to device and
serial.
Icon number.
see that
Console.
it's having a console.
Open console.
Arrow back down, arrow down,
See,
right to one window.
that's it. Now just
Below
Open console.
you give
Not open console.
that's why it's showing problem. You can see that the text is there, it's already signed.
So it's not updated. If you update that one, so everyone got this?
Sir, we have actually disconnect serial port.
Then resume button.
Serial resume.
Not showing.
Finish, right? Finish.
It's not showing. So if it shows like this, remove it.
you just check it again to make sure that document automatically follows you from because I am unable to install your and that only two statements are mentioned. That loop showing. Loop is there. While
loop.
That's the interface loop of that while is there. Na?
So these are maybe a sensor
Statement is that there you use the command.
Sensor is
First one is the
have you? No. Before that,
File
you
name.
just close
What file name? Go to the file. That blink LED is there. Na? Go to that. MP. It's a
Go to the
C.
projects, no?
Blink C is
right
there.
click on
Na?
the folder.
Yes,
C. Dot C.
Core
Core you go sir.
Core INC.
This your name.
Yeah, we have it.
Just open it. Maybe the sensor. Just mark the open.
Connect one more sensor. Wait. After this
Message is coming as MP that
is connected. It's connected. Then resume.
For you, what
Also
happens?
you see, sir. Top resume.
Same.
Now,
Same.
click the resume button. The same problem. I think the resume button is on. Then close it. Now, once again, what I do? Once again,
Once
click
again,
even
one
down.
time.
Only one.
Clicks. Close it.
All are there. Na?
Else it will ask you to update. Once again, you click the
It is not visible.
Click yes, click yes. Open and update all the notes.
I just saw it was December.
Now folder is
बड़ी सर सेंसर है और MPU 60 हाँ
My driver is not.
switch.
We are not able to see the.
So now you open the console.
SDA.
Right side, open console. Next, command.
SCL.
And there, have you created already? Then okay, click OK.
You
will go to symbol. It's next.
BCC is 3.0.
So just move the sensor.
Check
It's coming. It's coming.
we can
Okay, so now I think for 2-3 people got it. Now I just want to go to machine learning now. I'll go to machine learning now. So for that, what I do is, now the work of this is over, ID is over. I'll close this. I don't want this anymore now. You close this. So now you open that HAI, Nano HAI. I think you have installed, you have included the license already. Now, if you don't do this previous step with Nano HJ, you cannot work. So don't think that directly I can connect with Nano HJ and can do it, because we have configured those two pins as I2C pins. If that's not happening, directly if you connect to the Nano HJ, it will not work out. So always when you do any machine learning project, go to IDE, enable the required pins, then come back here. Okay? So see, the dashboard will be like this. Your Nano Edge Studio dashboard will be like this. Okay. So what you have to do is click New Project first. Click New Project, and it will show the multiple options. Okay, it will show the multiple options. Detect anomalies. We will do one project on anomalies also, and classify variation of signal. Detect outliers in your signal. Extrapolate. So what we are going to do is classification problem now. So just click create. Just click create. So your window will be like this. So I'll just give some name. Access detect. I just put some file name. Access detect. Just save it. So once I give the project name, next you have to select the target. So target the board what we are going to use it. So our target is 476 RG, okay? Or if you don't know where to get it, just click the target selection. There you can get the board. Okay, there you can get the board. Okay. So since I just put it in the favorite already, it is showing my board already outside. Okay, I just select the board. Okay. Once I select the board, you can see that memory footprints. It is showing 128 KB and 1024 KB.
What is your sir? I'm not connecting.
Sir, Manikanta sir, maybe after this session, the two chronicle cases are there, Sumant and Tarvin. Only these two are having first year backlog. One is good.
Only Tarvin is.
Tarvin. Sumant, obviously, you go for this one. Tarvin is there. Yesterday results came. You check the thing. He has cleared, it's fine. He is not clear. He has to go for fast track. You just discuss with me after this session. Then you have to ask him to do that. Yeah.
Ma'am, any third semester?
No, it's only final year. 22 batch. Yeah, okay, so I selected the board and you can see the memory footprint 128 KB RAM and maximum flash. So this is adjustable. Okay, so maximum RAM I'm assigning and maximum flash memory I'm assigning. So if you want to restrict, you can restrict, no problem. Okay, so here you can see that multiple sensors are already available for time series and for cross sectional some sensors are available. Okay, so we go with time series. Okay, and there are predefined sensors already. Suppose if you have any other generic sensors, you can connect here. Okay, but we are going with accelerometer. So just click this accelerometer. Once you click this accelerometer, it will show number of axes. You can see that. So ours is 3-axis accelerometer. You please select 3. Okay, then click save. Click save. So now it will go to the second step. This is the first step. So only the project setting. That's it. Okay. And in signals, now we are going to collect the data. Okay. So there are multiple ways to collect the data. Okay. Multiple classes of data. As I told, for this particular project, I am going to detect which axis I am rotating. Okay. So obviously I want data for XY, YZ and ZX. So 3 classes of data I have to create. Okay. Suppose if you have data already, you can directly upload also. I will show you that also. Okay. So how to do that? You can see the plus button is there. Okay. Click this plus button. You see that it gives you the option. Okay. So here you can directly upload your data. Okay. And the next one, log signal through serial USB. The next one is create data logger. So this is, as I said, CSV file, and create data logger. There are data logger boards are available. We can take that board. It's released by STM. You can take that board and we can collect the data. Okay, but ours is not that one. We are going to collect the data through serial USB. So just click this. Okay, so when you click this, you see that it will show the port of your device and baud rate by default 115.52.00. That you don't change it. And you can see that one more option, maximum number of samples. If you want to restrict, you can restrict. Okay. If you don't want to restrict, or if you want to collect the data for 24/7 for 365 days, you can leave it. You can still collect the data. Okay. Or if you want to stop anywhere, you can stop anywhere. No problem. Okay. So I'm not going to restrict anything. Okay. Just click start button. Once you click the start button, it will start collect the data. I'm just clicking the start button now. So before that, you keep the sensor ready. You have to keep, as I said, one is for XY, the other one is for YZ, the other one for ZX. Okay? So keep your sensor ready. Okay? See how I am going to collect the data. Please look at it. How I am going to collect the data is, first XY I am going to rotate like this. Okay. Then YZ I am going to rotate like this. Okay. ZX I am going to move like this. Okay. If I rotate like this, it will show XY. If I rotate like this, it should show YZ. And if I move like this, it should show ZX. Okay. This is my yeah, you can see that My data is coming now. I'm correcting, I'm moving in XY direction. You can see that my data is keep varying. It's getting moving in the XY direction. And you can see that at the top 29 signals, 30 signals like that. It is capturing the signals. Okay, I'm just taking for up to some 50 signals. I'll take it and I'll stop it. It's one demonstration purpose, or if you want to take multiple also you can take it. So still I'm moving it. Yeah, 50 signals came, I'll stop it. See now, XY data is collected. I stopped it. Okay, and now once you stop it, you can see at the bottom there is an option called next. Click this next. Okay, and it will ask you under what delimiter you want to save your file. Okay, whether it's a space or comma or semicolon, whatever it is. Okay, it will show you the option. But what we are going to do is we are going with space. Okay, space. Okay, then click import. Click import. Now my data came. Okay, now my data for XY came into my dashboard. Okay, you can rename this